Hello guys, and welcome to a quick tutorial on one of the very interesting setup we can do with the Niagara system, which is to draw the trace of a projectile. Okay, basically we wanted to be able to show a line that goes from the starting of a projectile to the end of the projectile. Okay, and that can be used for predicting the grenade you're throwing, or in a VR setup to project where you're gonna be teleporting into. Right? That's we can do that with coding, but it's important that we visualize that. Okay, so I'm gonna do right click and add a VFX and then Niagara emitter. I'm gonna call this guy new emitter, and it's gonna be just empty, and finish, and then will be NE, and I'm gonna call this guy arc. Okay, and then open that. And because this is the empty emitter, we wouldn't see anything. That's no problem. We can gradually adding in the missing things. The first thing we need to do is to change the previous scene so that we don't have the environment. We can even make the background kind of dark so that we can see it. Okay, alrighty. Now the first thing we need to do is to make sure that we do have the emitter update. We spawn a burst of particles. Now this is basically the particles we need to create our ribbon, right? And then we can go with maybe 10 of the particles. Okay, now we also need to, in the particle spawn, I'm gonna do a ribbon, or I believe it's in the emitter then, ribbon, or I was saying ribbon beam emitter setup. That's right. So this is some legacy things. They're called beam sometimes and they're called ribbon some other times. Anyway, so beam end, you can set up where the end of the beam is, right? But we wouldn't see it until we set up the beam render, I believe. But let me just change that to like 500 so we can see a bigger or longer beam. Okay, and then let's see, then we need beam stuff here, beam width. Okay, and then it's asking for a problem as unmet dependencies, spawn beam, fix that, sure. Okay, and then beam, spawn beam, nothing, beam width, I think that's fine. And then particle update, we can do a color update. Okay, we can do a beam update beam. Okay, now you can see we do have the particle laid out like that. Okay, alrighty. So in the final render there, we don't need to have the sprite render. We need to have the yeah, that's when it's called ribbon render. Okay, and we're rendering out the ribbon. Okay. The material is having a little gradient. Let's see if we have something that's simpler. I guess we don't. Or maybe we can show the engine content. We're showing engine content. Okay then. I guess we can just go ahead and make our own real quick there if you want to, or just particle. And no, there's nothing like that. So we're gonna make a new material now. I'm gonna call this guy M beam. Okay, and then for the material there, I'm gonna make it, of course, in the blend mode, shading mode. I'm gonna go with unlit. I think that'll be fun. And then I'm gonna create a particle color. Yeah, that'll be it. Just drag that over there, and it'll be fun, right? Just have it in there. Okay, and if you wanted to have the transparency, I believe you can have the transparency, translucent, and then we can pass in the alpha there, I believe. That'll be fun there. And let's use that M beam as the particle material. M beam. Okay, that'll be fun. Alrighty. So the beam is a straight line. We want to make it to mimic a arc, so we need to define a bunch of positions for that arc to go through, and we're going to use that with a simple scratch pad. So let me add in a new scratch pad. module. I'm gonna call this scratchpad position array to particle positions. Okay. And then we need to have a new input. I'm gonna call that of the vector array. Yeah, and name will be positions. Okay. And then we're gonna actually use these positions to reposition those individual vertices. And so we need to get their particle ribbon, and we have the ribbon link order. Okay, ribbon link order will be a value that's ranging from 0 to 1. The first point on the ribbon will have a value 0, the last one will have a value 1, and the ones in the middle are ranging from 0 to 1. This variable is per particle, right? And we can use that to find a proper position there to position that particle. Now the positions can have any amount of positions. We just get the num of that count positions array size or length, I guess. This is how many things are in there, right? And then we use that to multiply by the ribbon link order. Okay, what this does is to use that link order to determine where we are in the list, right? Now if we have that, right, then we can determine a position, but we have to make sure that we are flooring it. So the value is actually a value that's in the range, right? And it's a integer value there, right? And then we get one from there. Okay, get one from the index. And this one will give us a position, right? And this position will be used to set a particle position as the output. So position there, and we drag that over there. Okay, alrighty. So if we specify an array of particle positions, these positions will be proportionally distributed to all the particles here, right? That's the idea. I'm going to save that and also apply this. Okay, alrighty. So when this is over, then we can go back here to the overview. We can grab this guy now. We have the position array to particle positions. We have one input, the array elements, right? And let's test. Okay, so now we have nothing because there's no points. Let me add in a few points. So 0, 0, I'm gonna go for 200, 200, and 200. You can see now how our last point is in there, right? Let's add in one more. And then maybe we make this one 400, 400, and 400. You can see how we're arcing, right, from the beginning to there, right, very nicely. So you can see how this can be really helpful. Okay, now we can actually make a system out of this, and save that, and then close that and close that as well. And then we can make a system, Niagara system. I'm gonna call this guy, just create an empty system will be fun. I'm gonna call this guy NS arc, I guess. And this one will have our arc module. Add in there, yeah. Okay. And then we can specify our parameters, user parameters. We can add in one more, and this one will be a vector array as well. Vector array. And I'm gonna call this guy positions. Okay. And that positions will be feed into our position here. Let me clear that out, right? And it's one, and delete that. Vector array. I'm gonna link that to the user position. Yeah. Okay. Alright. So we can also again test it in here. So we have 1 and 2. The second one can be 200, 200, 200. You can see now it's doing the same thing, right? We can add one more, right? So it's able to arc through these. Not necessarily arcing here for some reason. Yeah, we should go to 0 for the Z, otherwise it's going a straight line. Yeah, that's fine. Alrighty, cool. So yes, as long as we can provide the proper locations, it's going to do the proper arc for us, right? That's the basic idea. Alrighty. So how do we use that in our code? So we can create a test blueprint. I'll call this guy aimer or something like that. Okay, the aimer will have we just in the event graph, right? I guess we can do that in the tick. Okay, let's add in a Niagara particle system component. Okay, alrighty, and the system will be our arc. It goes like that. Okay, and so when we're ticking, we can actually do a predict or projectile pass by, I guess, trace channel would be fun. Starting position be get actor position, of course, right? And then the launch velocity get forward vector. We can time that with a huge value. Oh, somehow I cannot pan the graph for some reason. Let me close that and reopen. Yeah, that works. So right click, we can actually convert that into a float and then make that like a 200, I guess. And that goes to the launch velocity there. Okay. And then trace channel word dynamic, I guess it's fun. Actor to ignore, I can make a array so that we ignore at least ourselves. Okay. And then we can also have the draw debug tab, okay, for one frame. And the important thing is the max simulation time. This is how long the simulation will be used to find out where the arc goes. If this is not long enough, you'll get false here. I think 2 is fine. We can go for 3 just to make sure that we are able to trace all the way to the ground. Okay, now we'll have the outpass positions, right? These positions will be then used to set up our Niagara system positions. Okay, so set Niagara variable array, set vector array. Okay, this is actually, if you're using C++, make sure that this is you're using the Niagara data interface array function library. It's a mouthful, but it's that library that's able to call this function, and the array data is there. And the name will be the name we set up as what we have in our here, the user dot positions. Okay, so user exposed, right? Can we copy the name, copy reference, and see how that one goes, and paste that in there? Yes, that's correct. So user dot positions is the one. All right. So in every tick, we're projecting, and then we're getting the positions from the projectile trace, and that will be feed into our Niagara system, right? Cool. So now if we play the game, have this one in there, right? Well, it looks like it's in here for some reason. Oh, because I guess it's the position is actually being set up already. So that's fine, right? We can try to simulate. You can see how it's doing that, right? You can see how our arc, right, our Niagara system is following the same trace as the debugged spheres. Those spheres are debug information from our function call there, right? You can see how we are able to do this. Are we movable? Yeah, we're movable. So yeah, can we rotate? Rotation doesn't work here. It's fun, but you can see how this looks like, right? And if we're moving in this thing, we should be able to get the result we want. And I think I'm not pushing forward far enough. Let me actually promote that to a variable. I'm gonna call this guy trace speed, I guess. Make that expose on spawn and instance editable, so we can actually test it in the viewport. Alrighty, now if I go change that to be something higher, you can see we're tracing further and further. You can see how it's almost always trying to match with the the debugging, right, of the line trace, and that's it. That's basically how you set this up, right? It's we're not doing anything fancy here, but that's the basic fun setup. You can actually go tweak the material, tweak the system a bit more to make it more fun. The emitter can have like things like the beam width, for example. The beam width can be based on the float from curve, right? And curve can be the link order, I believe, right? And then you can add a key in there from 0 to 1 to 0, right? These kind of thing. And then you can scale curve by like 20. So the curve will be arcing from beginning to the end. The last value is 1 there. Yeah, so the middle part should be bigger and the last part should be smaller. Right, you can have some fun with that. Let's see how this one looks like. Yeah, it's thinner there. It's not thinner in there. But you can see how we can have some interesting arc changes. Yeah, it is thinner actually in the beginning and thinner in the end. We can change the shape, we can do whatever we want, visibility or whatever, right? Transparency. So have some fun with that, but this is the basic setup. All right, that will be it for this video. Thanks for watching. See you next time.